Okay, watch and listen carefully here, guys. So we have a plane that starts from rest. So our first given is that VI is 0 meters per second. It travels 800 meters down a runway in 14 seconds. Okay, what is the acceleration of the plane? All right, so I've got VI, I've got D, I've got T, and I'm looking for A. So the only formula that can do that in one step is D equals VI times T plus 1/2 AT squared. All right, so 1 mark for givens, okay, and 1 mark for picking the correct formula. Now we need to manipulate for A. So the first thing I want to do is subtract VIT over to the other side. So I'm going to have D minus VI times T equals 1/2 AT squared. Since I'm looking for A, I'm going to divide both sides by half of T squared. Okay, and that will leave me with A. So when the numbers are plugged in, that's going to be 800 meters minus 0, because the VI times T is 0, okay, divided by 1/2 times 14 squared. All right, so give them a mark if they have it manipulated either with letters or with the numbers plugged in. Makes no difference. Okay, and then we'll figure out what that is. So we got 800 divided by 0.5 times 14 squared. All right, so the acceleration of the plane is 8.16. Actually, sorry, we only have 2 significant figures, so 8.2 meters per second squared. Okay, and they gave us a direction here, down the runway. Okay, I would accept forward if they had forward written there as well, even though the question didn't specifically say forward, it did specifically say down the runway. But as long as they have a relevant direction on there, I'll accept that. Right, so 1 mark for the answer, provided it has the right units and a relevant vector. Okay, mark for the manipulation and plugging, mark for the formula, mark for the givens. All right, questions on number 1. Okay. So for question number 2, I have a ball that is thrown upward into the air, and it, as we discussed yesterday, anything that's moving in the Earth's gravitational field is going to accelerate due to gravity. So our acceleration is negative 9.81 meters per second squared, okay, or down. Its velocity, when its displacement is 13 meters up, so D is positive 13 meters, okay, its velocity is 8.3 meters per second up. So that's VF. And that's positive as well. All right, so we are looking for its initial velocity. 1 mark for their givens. Okay, the formula that can solve this for me in one step is VF squared equals VI squared plus 2AD. Give them 1 mark for that. Okay, so we have to manipulate for VI. So I'm going to subtract 2AD over to the other side, and then I'm going to square root that. Nope, sorry, to get VI. Okay, so if the number's plugged in, okay, that'll be 8.3 squared minus 2 times negative 9.81 times 13 meters. So give them a mark if they have either one of those. All right, so our initial velocity was 18 meters per second. Up. They must have the up in order to get that mark. Okay, so it's out of 8. Give them a mark out of 8. Let them see it, and then I would like them on this desk right here, please.